everybody, welcome to my YouTube channel Easy Mathematics. In this video we are going to discuss a special type of sequence. The sequence is Arithmetic Geometric Sequence. In short we can write it is AGS. So Arithmetic Geometric Sequence, how it looks like. If each term of a sequence is the product of the corresponding terms of an AP and a GP, then it is called the Arithmetic Geometric Sequence. How it looks like? So first term is A, second term is A plus D into R, third term is A plus 2D into R square, and likewise. Just look, first term is A into 1 we can say, or just let it be A. Second term is A plus D, third term in we have A plus 2D. So this part only if we consider, then this one is an AP. And R, R square, R cube, this one if we consider, then this one is an GP. So if each term is the product of a AP term and a GP term, then a sequence is formed. This one is called the Arithmetic Geometric Sequence. So at first we should find out the nth term of such kind of sequence. So it is so very simple. Nth term means, so the term is the product of a AP value and a GP term. So AP term for the nth term is A plus n minus 1 into D. And for GP term the nth term is R to the power n minus 1. Here we just write this one as a because this one is the product of this one. So this one is our Tn. Now our requirement is the summation of this given sequence. So sum of n terms for any arithmetic geometric series, if we want to find out, then it is Sn is equals to A plus D into R, A plus 2D into R. In this way we just add all those up to the nth term. So now to find this Sn, how we will find out actually. So there is a simple process. If you will find out any such kind of series, then to find out the Sn, at first multiply both sides of the equation by R, the common ratio of the corresponding GP, and then subtract as in the following way to get a GP whose sum can be easily obtained. So how we will do? Sn is equals to this one. We just multiply R with this Sn, and after multiplying this R on both sides, we write the terms just by one shift. So R Sn is equals to, we should write AR plus A plus D into R square, plus in this way it is the previous term of the nth term and this is the nth term. Now if we subtract these two, then we will find out 1 minus R into Sn is equals to A first term. Then this one if we subtract, then we will find out D into R. Next we will find out D into R square. Then this way we will find out. Just look at here, the last term we should write just as minus of A plus n minus 1 into D into R to the power n. It is R to the power n because we have multiplied one R here. So now for Sn, how we will find out it is? Just look, A divided by 1 minus R we should write. Here no confusion. Now this dr square, in this way up to dr to the power n minus 1. This one is an GP series now. So in this GP series, the common ratio is R. First term we can say dr, or we can take dr common even. If we take dr common, then it is 1 plus R square. In this way up to R to the power n minus 2 it will continue. So that total here n minus 1 number of terms, so that we can write dr into 1 minus R to the power n minus 1 whole divided by 1 minus R as from the formula. And for this 1 minus R it becomes whole square. And for this last term, this is A plus n minus 1 into D into R to the power n, remaining as it is, just divided by 1 minus R. So this one is the summation of this arithmetic geometric series. Just remember here R should be not equals to 1, because if R equals to 1, then it is undefined. So now if this arithmetic geometric series going up to infinity, that means here the finite term for, if your number of terms for the arithmetic geometric series is finite in number, then this one is the formula. But if the number of terms are infinite, then what happened? If the number of terms are infinite means what? N should be tending to infinity. N tending to infinity means here we will find out R to the power n is equals to 0. So that we can say R to the power n minus 1 is also 0 as n tends to infinity. So that from here we will find out r to the power n minus 1 is 0. So that term becomes 0. Likewise here r to the power n tends to 0. So that this one becomes 0 means this entire portion becomes 0. So that if sum we are calculating for n is equals to infinity, then what we will find out? So then we can say as n tends to infinity, Sn becomes limit of n tends to infinity of this term. And if we take n tends to infinity, then this part only is 0 and this entire part 0. So that we will find out a divided by 1 minus r plus dr divided by 1 minus r its whole square. So just look, S infinity is this one when r is not equals to 1. So in this way, we can easily find out the sum of the arithmetico-geometric series. Either it is finite number of terms are there or infinite number of terms are there. Now let us do one example corresponding to that type of series so that we can understand it better. So the question is, find the sum of n terms of the series 1 plus 4 by 5 plus 7 by 5 square plus 10 by 5 cube plus dot dot. Just have a look that 1, 4, 7, 10 these are in AP with common difference is 3, and 1 by 5, 1 by 5 square, 1 by 5 cube these are in GP with the common ratio is 1 by 5. So that accordingly we can say Tn is equals to a plus n minus 1 into d into r to the power n minus 1, where a is equals to 1, d is equals to 3 and r is equals to 1 upon 5. So if we substitute and simplify, then we will find out Tn is equals to 3n minus 2 divided by 5 to the power n minus 1. Now for the summation, what we will do, we directly can substitute the value. So Sn is this one, and so that the summation of this one should be a divided by 1 minus r plus dr of 1 minus r to the power n minus 1 by 1 minus r whole square minus of this nth term into r divided by 1 minus r. Okay, so this one from the formula which we will find out here, as total n number of terms are there, so that we use this formula. Now we should substitute the value for the corresponding term. For a is 1, r for 1 by 5, d for 3. So if we substitute all those, and Tn for it is 3n minus 2 divided by 5 to the power n minus 1. So if we substitute so and simplify, then we will find out it is 5 by 4 plus 15 by 16 into 1 minus 1 upon 5 to the power n minus 1 minus of 3n minus 2 divided by 4 into 5 to the power n minus 1 is the answer. Now if the same sequence is an infinite sequence, that is the infinite series, then what should be the value? If it is the infinite series, then what happens? This term becomes vanish. Not only that, this term also vanish. So that we will find out only 5 by 4 plus 15 by 16 if it is the infinite number of terms are there. So that S infinity should be 35 by 16. So that is your answer. So just substitute the formula, we will get the answer. Otherwise, you know the process. If you forget the formula, then also it doesn't matter. Just simply go for the process and you can derive the formula and substitute the values to get your desired answer. Now, what happens? Sometimes we have some series which are not a proper form, not in a proper form. So there are so many series which are not directly arithmetico-geometric series, but after some transformation, it can reduce to the arithmetico-geometric series. If such kind of series are given, then how to solve them out? For that, I am giving you one more example. So find the sum of the infinite series 1 square plus 2 square into x plus 3 square into x square in this way. So just look at this one. This is not a arithmetico-geometric series initially. Here in this series, 1 square, 2 square, 3 square, 4 square, these are neither in AP nor in GP. So that what to do, we will just observe that 2 square minus 1 square, its value is 3. Then 3 square minus 2 square, its value is 5. Then 4 square minus 3 square, its value is 7. So that this 3, 5, 7, this one forming an AP. So what we will do, if it is the infinite series, then S infinity is this one given. So we just simply multiply x with this one and then just add with this one. So x we just multiply in this entire term and we just write again, just shifting one term, and after that we subtracting. So if we will do so, then we will find out here 1 minus x s infinity, that is as there are n number of terms, that's why I have written s infinity, is equals to this one here, 1 square plus then 2 square minus 1 square into x, then 3 square minus 2 square into x square. So that we can write it is 1 plus 3x plus 5x square plus 7x cube in this way. Now this is the arithmetico-geometric series because 1, 3, 5, 7 these are in AP and x square, x cube these are in GP. So that in this arithmetico-geometric series we will find out a is equals to 1, d is equals to 2 and r is equals to x. So that we just substitute here, we just keep 1 minus x in this side only. We are not going to divide by this one here. After that, this one is equals to, as a formula, as it is the infinite series, so that it is a divided by 1 minus r. A is 1, r is x, so that we will find out 1 divided by 1 minus x plus of similarly 2x divided by 1 minus x square. So that if we simplify, we will find out it is 1 plus x divided by 1 minus x square. So that now our requirement is s infinity. So that s infinity, finally we will find out it is 1 plus x divided by 1 minus x cube. So this is our answer. Now it is the time for do by yourself question. I am giving you one question and I hope all of you can able to solve this one, and definitely its answer I am expecting in the comment box. So the question is, the sum of the series 1 plus 2 into 2 plus 3 into 2 square plus 4 into 2 cube, in this way 100 into 2 to the power 9 is what? Option A, B, C or D? Write down your answer in the comment box. I am waiting for that. Have a nice day and thank you all.